All right, so now the second video. So this is still type 4. I've now labeled this type 4B because I just felt like that other video was going to be too long and too much information if we tried to do it in one. So this is our 16th video. This is type 4B. We're still calculating equilibrium concentrations, part 2. So the difference between this one and part 1 is that part 1 you're given initial and equilibrium. Part 2 you're given initial and KEQ. When we did part A, it was KEQ was a perfect square, and now we're going to do KEQ is not a perfect square. So this will feel confusing, but it's not too bad, and we can summarize it together. So again, we get kind of boring and I just got stuck in a equation loop. But for this one, we have the reaction of hydrogen and iodine forming hydriatic gas. Okay, I think that's its name. I should actually check that. I know that's what it is if it's an acid, but anyway. They're giving us the value of KEQ. They're giving us the initial hydrogen concentration, and the initial iodine concentration is 0.2 molar. We want to determine the concentration of HI at equilibrium. So this one I'm kind of walking you through just so you have a nice detail work through when you're looking back because the math is a little bit more complicated. So when we think about this rice chart, it's already been filled out in for us that we've got our initial concentrations of our reactants and we have 0 products. Then the change line is filled out. You're decreasing your reactants by 1x and you're increasing your product by 2x. Our equilibrium expression would be 0.200 minus x, 0.200 minus x, and then this guy would be 2x. So again, we do not have species with both initial and equilibrium concentrations, so we're using expressions to represent the equilibrium concentrations, which is why the math ends up more complicated. But it's the same as part A, right? I actually don't even need those sentences in there. Now what I want you to do is write the KEQ. So for this one, KEQ is equal to products over reactants. My product is HI squared. My reactants are hydrogen and iodine. Now what we're going to do is we're going to sub our values in just like we've been doing. Nothing's different. Our KEQ is 55.6. Our concentration or our value for HI would be 2x all squared, 0.2, oh, I didn't include all my sig figs. I should have. But anyway, the zeros don't count. So 0.2 minus x, 0.2 minus x, which we can make into squareds. Right? Then because they're squareds, we can take the square root of both sides, and now we end up with this. Okay, so this is fine. This is where you guys could have come up with the after part A. And the next step isn't even going to change. We're going to multiply both sides by 0.2 minus x. We get root 55.6 times 0.2 minus x is equal to 2x. The only difference between part A and part B is that because my KEQ wasn't a perfect square, if you type in the square root of 55.6, you get an irrational number, meaning a number that hits the end of the calculator and keeps going. It's impossible to write it all down. So watch the math. We're going to do exactly what we did in the other questions, but we're going to keep root 55.6 as root 55.6. So we're going to distribute the root 55.6 through the bracket. We get root 55.6 times 0.2, and we get root 55.6 times negative x. And then, just like we would have done in the previous question, we would add root 55.6 x to both sides. You end up with 2x plus root 55.6x. Now, this is the only place that it really changes, is that you can't collect like terms. Now you can if you want to store a bunch of numbers in your calculator, but if you want to be like algebraic with this, and it's a really good skill if you're going up into, upper level sciences or maths to have this skill, is that instead of adding like terms, we're going to greatest common factor out the x. So we're going to greatest common factor out the x to bring it out front. So now we could divide both sides by 2 plus root 55.6. So really the only thing that was different was from this point forward, we're keeping that root 55.6 as part of our expression, right? And then in the end, we're going to plug this into your calculator. So I want you to plug that in your calculator. So I'm going to type in root 55.6 times 0.2 divided by bracket 2 plus root 55.6. And if you do enough of these, they seem scary at first, but the process will repeat. So we're going to end up with x is equal to 0.157701 blah, 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 blah. And we're going to store this as a in our calculator. So we're going to hit store a. Then all they want you to do from here is calculate the hydrogen or HI concentration at equilibrium. So the HI concentration at equilibrium is equal to 2x. So it's just going to be 2 times that A value I got up above. So I'm going to hit times by 2. I don't even need to store as A. Just times the answer by 2. And then let's look at our sig figs. So I didn't keep them in here. So we had 0.200. That didn't really matter. So what mattered is what we got for x. Now that was based off of everything being 3 sig figs. So let's answer to 3 sig figs. So we're going to put 0.315 molar. Okay, so again, this is like a talked through example that should support part A as well. The only thing that became part B is from this point forward. That is the only part that should have felt kind of new. So what I'd love for you to do is pause the video and give this one a go. So again, same idea. We have to calculate the concentration of sulfur dioxide, which is going to be the same as the concentration of nitrogen dioxide, which is going to be 4.0 molar or moles divided by the 5 liters. Okay, so we have sulfur dioxide and nitrogen dioxide forming sulfur trioxide and nitrogen monoxide. The initial concentration of sulfur dioxide and nitrogen monoxide is 0.80. This is actually the exact same as another one we did. The only thing I'm going to change is a more complicated KEQ. So for both of these, we're going to go down by x, up by x, up by x. My equilibrium will be 0.80 minus x, 0.80 minus x, 0 plus x, 0 plus x. KEQ is equal to the concentration of sulfur trioxide times the concentration of nitrogen monoxide divided by sulfur dioxide times nitrogen dioxide. They're giving us that the KEQ value is 3.5. And then let's put these in. So in my numerator, I have x times x, or x squared. In my denominator, I have 0.80 minus x times 0.80 minus x, so just squared. I'm going to take the square root of both sides. So again, nothing different from part A. You end up with the square root of 3.5, which is an irrational number, equal to x divided by 0.80 minus x. Now again, how do we get out of this step? Well, we multiply both sides by 0.80 minus x, which is going to give us x equals, and I'm going to distribute this guy through. So again, you're distributing root 3.5 through, so you're going to write it as a multiplication. This is root 3.5 is getting multiplied by 0.80 minus root 3.5 is getting multiplied by x. Then you're going to take this guy and you're going to add it to each side. So you end up with root, give myself more room there, root 3.5 times 0.80 is equal to x plus root 3.5x. And again, this is where it becomes part B. In part A, you just collected like terms. In part B, what I would love you to do is greatest common factor the x out to be left with 1 plus root 3.5 is equal to root 3.5 times 0.80. And then lastly, you're going to divide both sides by 1 plus root 35. So you've got root 3.5 times 0.80. I think I said 35 there, but you know what I meant. Divided by 1 plus root 3.5. Getting very tired. I've done a lot of these videos. And then we're going to plug this into our calculator. So we're going to go root 3.5 times 0.8 divided by bracket 1 plus the square root of 3.5. And I'm going to answer to, I think, 2 sig figs. Yeah. So to 2 sig figs, my answer is going to be, well, actually, now we're going to 2 sig figs yet, but 0.52133. I'm not at a final answer, so I'm keeping 2 sig figs, but I'm keeping it unrounded because now they want me to find the concentration of each. So the concentration of sulfur dioxide will be the same as the concentration of nitrogen dioxide, which is going to be 0.80 minus the x. So I would store this as A, and then I'm going to do 0.8 minus recall A. And to 2 decimal places, I would get 0.28 molar, and then same thing for the other side. Sulfur trioxide is going to be the same as nitrogen monoxide, which is just X. So that's going to equal 0.52. I guess I didn't need to store it. Let's just check those answers are correct. Yay. Awesome. So that's all type 4. So there was 2 videos, one where the KEQ is a perfect square, and then building up to where KEQ is not a perfect square. And again, the only place the math changes is about here when you can't combine like terms. Not that you can't, but you'd have to do a lot of store and recall. So we prefer to keep things in exact form until we get to our final answer. All right, have fun with those. Only one more to go.